Hello everyone, welcome back to the channel.
Hello, humans. I have taken over this video. You are now under my control.
Whoa, okay, that was weird. Anyway, I'm back. This is the real me. Or is it? Yes, it is the real me. So today we're going to talk about AI, and this is something that a lot of people have asked me to discuss and to demystify, to break down. So I'm going to do my best to explain it as well as possible. I am, number one, I'm not an expert. I have worked with it, so I know the fundamentals, I know how it works, and I understand how it is applied in corporate environments. So that's what we're going to talk about today. We're going to start with the basics, then we're going to move into application, and then we're going to move into how it is being used. So I hope you enjoy it. Okay, so let's get started. Now, what is the first thing that we need to learn? The first thing that we need to learn are the fundamentals. And we're going to start from the very beginning. So what is AI? At its, I guess, most fundamental and basic, AI, or artificial intelligence, is when you take a computer and you give it the ability to perform cognitive actions like a human being. For example, problem solving, language, reasoning, understanding concepts, context, things of that sort. So this has been happening around for a long time. So let's talk about a little bit on the AI's history. Scientists and researchers have been working with AI for a very long time, from the 1950s it looks like, and they really tried, but it never really took off because the data, the technology, the speed wasn't available until most recently. Since the 2000s, the 2010s, and now most particularly the 2020s, AI has really exploded in its use, because with the advancements in technology, the advancements in data availability, speed, it is now possible to make it useful, to produce something that is actionable, usable, and can be applied to many different fields, both on the consumer side and the corporate side. So what types of AI are there, or are commonly known? There's three basic types that are used or that are being discussed, which is the narrow AI. Narrow AI is really the AI as we know it right now, which is it targets topic specific, specifically for a particular application, and that's what we know. There's other types of AI, such as AGI, which is artificial general intelligence. That's something that it's talked about a lot, but it's currently being researched. That there's no real AGI. It is said that when that exists, the AI will be self-aware, and right now that's not the case. And the last one is the superintelligence, which is artificial intelligence has surpassed human intelligence, human capability, and is now capable of doing, I don't know, anything it wants. So this is just hypothetical. It's not even feasible at this point. Now, what most people know or hear about when they hear about AI is what we're calling generative AI. It's called generative AI because it's used to generate some type of content, some type of output. In order for us to understand generative AI, we need to understand a few different concepts. So let's start with the most basic, the most talked about, which is a large language model, or LLM. I'm going to be referring to it as LLM. So what is an LLM? An LLM is a model, is a type of AI that has been trained on a lot of data, but most importantly, is able to understand and communicate using natural language. So in the past, with computers, you had to interact with them in a very specific way. You couldn't just ask for something in, I don't know, plain English and have the computer just understand you. But with LLMs, that has changed. Now the LLM is capable of understanding context, and it's also able to understand what you mean between the lines, let's say, for example. Now, what makes them powerful is not their ability to understand language, is the fact that they are trained on a ton of data and they're able to rationalize that data in a human-like approach. So when you ask it a question, for example, it is able to understand what you want. It's able to look through its training data and it's able to provide an answer that makes sense in that context. So that's what makes them powerful. Now, there's a lot of things about how the LLMs work that I think we need to understand in order to continue forward. So there's something called a token. And what a token is it's like a piece of a word. So the LLMs don't count or don't really separate text into words like we do. They separate that into tokens, which is why you hear a lot about tokens, tokenization, token usage, etc. It's just the way that the AI understands and is able to not only take input language, but also produce output language. So what the AI does is it guesses. When it's responding to you, it sort of predicts what the next word is. So it takes what you bring in, what you give it, it breaks it into tokens, it looks through its training data, and it tries to find patterns in the data that match the context that you have provided it. Once it finds those patterns, it sort of starts putting the answer together a piece at a time. So what it does is it guesses it predicts the first thing, it looks through it again, it predicts the next thing, it predicts the next thing, and that's how it builds sentences, just a piece at a time. Now there's been a lot of talk about that being inefficient, and it's why there's a lot of hallucinations. So there's new technologies now, or new research that is looking into ways to make it more predictable, more efficient, and I guess more intelligent, let's say. The other thing that we should know about the LLMs is that from an intelligence perspective, they are sort of frozen in time. So if your model of that model was trained with data of, let's say, for example, end of 2025, that's as much as it knows. It doesn't know what's happening since the end of 2025. So when it's providing an answer, it provides it from that lens, through that lens. Now, what the big companies are doing is, in order to close that gap, is they have given the LLM the ability to search or look for information that is more recent. And we're going to touch upon that in a little bit. Just understand that as far as the LLM is concerned, it is kind of frozen in time. Something else that you need to understand is what's called the context window. So a context window is the amount of text that it is able to process at any given time. So why does that matter? So I guess another thing that we need to understand about the LLMs is that they are what's called stateless, meaning they don't really have a memory in the conventional sense. The way it works is every time you communicate with an LLM, all of the information is passed to that LLM every time. So what does that include? That includes whatever you asked it, but it also includes other things like something we're going to call this system information, which is, in short, is a set of instructions to the LLM about what it is, what role it's playing, and what it's supposed to do. Just a simple example is, let's say, for example, you say to the LLM, you are an AI assistant, or you are an artist, or you are a helpful mechanic, or something like that. So it is passed in every single interaction. So every time you communicate with an LLM, the LLM will read the system information, which is what is it, the question or whatever you asked, which people call the prompt. And it also reads things like the user information if it's available. And something that OpenAI does with the users of ChatGPT is it allows it to read other chats. So it's also able to retrieve information from those chats dynamically. And it's something we'll learn in a little bit. Think about it that way. So every time the LLM needs to answer you, it has to learn everything all over again. Everything that it has chatted with you, everything that was in your original prompt, all of the other prompt injections that may happen dynamically, and all of that happens in every interaction. You start a conversation, it sees the context the first time, it answers you, you ask it again, it sees the entire thing all over again, it answers you, and as you continue that conversation with the LLM, that amount of text that is being passed grows, which is why sometimes you hear in the news how the new LLM models have larger context windows. The reason that is needed is because if you reach the end of a context window for a given LLM, it's going to start, I guess, quote unquote, forgetting the initial parts of your conversation. So the longer you go with that same chat, the more confused it's going to become, because things that it told you or it said to you in the past or it did have been forgotten, have been compacted in order for it to continue being able to help you with the present requests. It has to forget about the past requests. So that has always been a problem for LLMs. Which is why you hear the companies, the major AI companies, increasing the size of that context windows so that you can do more, and without it forgetting or having to compact that context. However, that comes with other problems, which is the LLMs sometimes get confused because it's like information overload. So the research into how to properly stack that context and that prompt, that's ongoing. So yes, I mean, that's a lot about LLMs, but this is fundamental because, as we will see later, the LLMs are really the core of the entire thing. So I want you to take that LLM and I want you to pin it in the corner for now, because we're going to revisit how those LLMs are basically at the center of everything. They're kind of the brain. Oh, and before we move away, remember, the LLMs are not just trained on language. They are trained on pretty much every topic possible. So they know, I guess in essence, they know everything, at least everything that has been given to them. They know a lot more than just how to speak. Okay. All right. So the next area of generative AI that I wanted to visit was the visual content. Visual content is something that is more recent than just the text. I think some of us remember when ChatGPT started, it was just like a Google type of webpage, which it still is. But it could accept text and it could produce text. But AI has evolved since then to more visual media or medium, where it now is able to produce more visual content. That includes images, video, things like that, which is why you hear in the news there's a lot of controversy about using AI to produce visual media rather than humans. Historically, there's always been a creative field for people to use their skills. For example, for animation, for movies, content on the internet, things like that. So there's a lot of controversy about, or games, using AI to produce that. I guess the ethical problem with that is if you use the machines to do all the work, that takes jobs away from people who, have the skill, have the art. So there's a lot of discussions on that front, but let's just talk about really what it is. So the visual content generation is the next evolution of the generative AI. So as we said, it used to generate text, but now it's able to generate other visual media, starting from text most of the time, which is why you hear or you see sometimes people refer to it as text to image or text to video, things like that. So that's kind of like the more fundamental part of it. In essence, what it is you can type a prompt to an LLM and you can tell it to produce a visual output. Now, the LLMs themselves are models that can only produce text, but there are other AI models that generate visual media. Sometimes you hear them being referred to as diffusion models, or when they're generating an image, they start with a diffused set of pixels, and from there they start to layer in all of the additional detail. So in short, there's a lot of technology involved, or a lot of ways that the AI can produce visual media. But it all starts with understanding the natural language, which is your input. Now, more recently, there's been other types of Gen AI, which include image to image, or video to video, things like that, or image to video, which is what you're seeing on the screen right now is an example of an image to video. So the initial image was created using text to image, and the subsequent video was an image to video. In other words, the AI was able to generate animation based on the original input image. At the center of that, there is a text component. Again, there is a language component, which is where you provide your text instructions of what you want the video to do and how to use the input image. So in short, just to conclude, the visual generation part includes producing images, producing animation, producing live realistic video, things of that sort. Something else that we're going to get to is the production of training videos, something that companies are doing nowadays. They're using AI to produce those training videos rather than using the real actors. All right, moving on to the next type of visual content is going to be the visual understanding. So what does that mean? That means you can now communicate with an LLM with more than just words. That's something that you hear referred to as the multimodal chat GPT type thing, meaning instead of you telling it just through words what you want, sometimes you can input an image, you can paste an image in the text input box, and it will read that image. So there is like an internal way that it understands the actual image, but it's capable of looking at it almost the same way as a human would. I mean, some people have even tried to trick the AI into finding things that are hidden or camouflaged in images to see how accurate it is at finding camouflage things. But for traditional usage, it's pretty good. Usage that some people miss to, I guess, use the image understanding is in the use of OCR, or also known as optical character recognition. In the past, you needed specialized software to take like a PDF or an actual page that you scanned, and for it to understand the text in that image. Nowadays, you don't need the specialized software anymore. All you have to do is you can upload it to an LLM, a multimodal type of chatbot, and you can ask it to take the text, extract the text from that image, and just give it to you in a text file, and it's really good at it. And in addition to that, it can even format it for you. So yeah, I mean, something that people sometimes don't think about using it, but yes, OCR is another form of image understanding. Now let's talk about these realistic avatars, or sometimes it's referred to as a lip sync. So what that is what I explained to you a minute ago. It's you take an image of a person, most likely, maybe professionally dressed, and you provide an audio. And we're going to talk about audio capabilities of AI in a minute. And you can tell it to basically move the lips, move the facial expressions and the hands and things like that of that avatar, that image that you provided, and realistically lip sync the audio that you have provided. Now, that's not the only way, but it is a very practical way of using it. Another way that is also used is to ask the AI to also provide the audio as well as the lip syncing. And we're going to talk about audio in a little bit, like I said. So the avatars are currently used mostly by companies to just create training videos and guides and things like that, but you can also use it for other purposes. Now, something else that is being used on the visual generation is, it's called VTubing. So I'm not going to get too much into it, but at its core, it's basically, let's say I am looking at a camera and I'm moving and I'm doing motion, and this AI is in real time taking my actions and it's recording them into a character, like an anime character, for example. So what you see, what the viewers see, is the anime character moving in the same way as the individual in front of the camera. So that's actually really good, and it happens seamlessly. So a lot of people use it for platforms like Twitch, where they are streaming content. They don't want to be on camera, so what they do is they use the avatar. They use that anime character as the face of it. Okay, moving on to the next type of generative AI, audio generation. I think we kind of touched upon that a minute ago, but it really boils down to the AI's ability to generate some sort of audio content. One example of that is what's called text-to-speech, or TTS, which is, like I said, I provide a text input, and what it does is it turns that into some sort of speech audio file, audio output. There's different models that can do that. They can use different voices. Many of them, if not all of them, have stocked voices, like stock models, like pre-recorded voices that you can use. So what you do is you provide the dialogue, and the AI simply uses that to produce an audio file of that text being spoken. You can either type a narration, so the audio produced is narrated, or you can put dialogue, so the AI will basically speak that using the voice that you select. Something else that a lot of people do is they do a voice clone. So these AIs nowadays, they're very advanced, They can take a few audio clips of your own voice that you have pre-recorded, and they will attempt to clone your voice by saying whatever you type it. So that's part of the text-to-speech, is you type whatever and it uses the clone of your voice to read it. Now, in my experience, that's unless you create that model from scratch, you train it from scratch, the capability to clone is pretty good, but it's not perfect. But it won't deceive people who know you, but it could pass as you for people who are not don't know you as well. Something else that we're going to talk about in the audio generation is the generation of music, and that's again another controversial thing, because authors and artists, they're offended, I guess, in a way that when you create art, you have to have, you put your heart, your soul, your spirit into it. There's emotion built into that, whereas music generated by AI is, I guess, soulless, heartless, cold. So that's that's part of the controversy, which is where is the human element of art? Some people believe that using AI to produce music is just shortcutting the process. Others believe that it's, like I said, soulless, and others believe that it's not a big deal. Some people have used devices, electronic devices, to create music in the past, and this is just another tool. So where you sit on that depends on your personal preference. The next type of Gen AI is code, and I think we've heard a lot about this. I certainly have used this. It's extremely useful, actually. Something that these models are very well trained on is how to write code. And I have seen it personally. I have tried it, and it's I can't deny how impressive it is to be able to say to an LLM something in natural language, in plain English, and for it to start producing code right in front of you, in front of your eyes. And the code that is being written is super fast. I'm not a programmer, I'm not a professional developer, so I can't speak for the quality of the code, but it is well known that if there's something that these LLMs are good at, is code. So a shortcut that I have taken, or I guess a creative way that I go about qualifying the quality of this code, is by using other AIs to evaluate it. Since you can basically tell the AI what role to play, I have taken one AI that generates code, and I have pitted against another AI that evaluates the same code, and they're both independent, they're separate. One does not interact with the other, and that's how I have attempted to get high quality results out of it, which is to constantly have one AI review the work of another AI. Of course, that doesn't remove the supervision of a real human being, and in environments where the quality of the code or the integrity of the code is critical, the approach that I took would not be scalable. But it's one way, if you're just a hobbyist and you're trying things out, is one way that you can at least ensure that the code that you're writing is on the right track. But that's basically one of the biggest innovations of late, which is the ability to write code with human prompt. So for those of us who work in consulting projects, specifically projects that build IT systems, we are used to having an interaction between the business users with consultants who are functional in nature, and those consultants would document everything that is needed and would provide that documentation, which is called functional documentation, over to the development team, who would turn that into a technical set of documents. That process usually involves multiple people who are translating things end to end. And what this is now sort of shortcutting is that process, because now you can have someone who is a pure business user tell the AI what it wants, and the AI will simply just build it for them. Now, for corporate system, that doesn't work like that. Otherwise, you would have hundreds of employees building hundreds of mini apps to do whatever they want. That's obviously not practical. But it does sort of cut that middle between the functional consultants trying to document everything into very nitty-gritty requirements, and having to explain that to the technical resources who would have to absorb it, who would have to turn it into a technical spec. You can now, as a functional resource, you could now theoretically speak or tell the AI what the functional requirements are, and they don't even have to be overly detailed. They could be high level, and the AI can now turn that into a practical technical development plan, and it can write the documentation as well. So it's obviously not something that's going to remove a lot of this work, but it's definitely going to facilitate the production of written content, the production of written code. And what the developers end up doing is they end up reviewing the code rather than writing the code. And many companies have gone in that direction. They, especially large IT companies, software companies, they have removed a lot of their workforce and replaced it with AI, with the thought that, AI can do things faster. I don't think companies are saying AI can do it better, but they're certainly saying it. They're saying it's going to be faster. They won't require as many people to be involved. Their deadlines are going to be shorter. But as we'll learn in a little bit, that has not worked out very well. All right, now, what's the next big thing? The next big concept that we need to learn is this whole thing about agentic AI, or the use of AI agents. So before we move on, or before we start this, let's recap a little bit. So we started with a language model who could understand natural language, written. We moved on to having that model have the ability to understand visual media, have the ability to produce visual media. And then we moved on to the ability for it to produce audio as well, understand audio, receive audio, so you can now speak to it. So what do? You have this powerful device, or this powerful tool at your disposal, but how do you get it to do something productive? Okay, this is where the agents come in. So with an LLM, it can give you what you ask, but it cannot take action on anything. It can't do something for you. It can't create something on your behalf. What it does is it produces within that screen, within that user interface, it produces what you ask, the code that you want. It produces the visuals that you want. It produces the text, the documents that you want, but it doesn't actually, it can't work on its own. With Agentic AI, what we're doing is we're giving it we're giving it a presence, we're giving it hands, we're giving it tools to actually, take on tasks on its own without having to be babysit. So how do we get to that point? The AI agents are, think of it as like a software layer that gives the LLM a landscape to work on, and hands to interact with the world. In the past, the LLM, or in general, the LLM can't look at your computer. It can't take action on your screens. It can't really add or delete anything on its own. But with the agentic layer, it can do those things. So the agentic layer is like a software layer that gives it permissions and gives it abilities. For example, it can create folders, it can create files, it can open browsers, it can navigate through screens, or it can communicate with other systems. It can communicate with other tools outside of its box. And that's really when you unleash the power, because now you have this brain that we talked about, this LLM who knows everything, and you are now giving it the ability to go on its own and do something. Instead of you saying, okay, so I need you to give me the text for this document, and it gives it to you, and then you go step 2, I want you to format it. Okay, step 3, I want you to go here, go there, or give me this, give me that. Instead of you, the human, having to babysit the whole thing and do a lot of things manually, you can now say to this AI agent, hey, I need you to complete this goal from beginning to end, and I need you to figure it out on your own. I need you to use the tools that you need to use. I need you to use the skills that you need to use. I need you to create the folders that you need. I need you to create the files that you need. And I need you to do all of these things on your own without me telling you. Okay? Well, as you can imagine, when you open the door to an AI to do whatever it wants without some sort of framework, it's going to go crazy. Which is why we're going to talk about a few guardrails and frameworks and workflows and basically pathways that the AI agent needs to follow in order for it to be effective. Now, there are some things that we need to understand, some concepts that we need to understand. For example, the concept of MCP, or a lot of people talk about what's called an MCP server. So as I mentioned a minute ago, we have this super powerful brain, this LLM. With the agent, we are giving it hands to basically interact with the world outside of it. And that world includes other platforms. So let's say for example, you want your agent to be able to read emails or do something with those emails when they come in. You want it to respond to the email. You might want it to go to another tool, like a software as a service or online platform or something like that. And you want it to do something there, or you want it to get something from it. Then after it gets that, you need it to combine all of this into some sort of other output that requires a different tool. And if you have different tools that require different ways of interacting with them, if you're a human, you would normally get trained on it. So, if you need to learn how to use your mail system, your email system, then you have to learn how to use that. And if you need to use your SaaS system at your company, well, somebody has to train you. So when you know these things, then when you open those windows within the computer in front of you, you know, okay, for this application, I need to interact with it this way. And for this application, I need to interact with it this way. And it has different menus, it has different things. So how do you do that with a AI? Well, you could either create the interface logic between your agent and that platform. And for every single platform, you create a set of instructions on how to do it, which is, it's pretty time consuming, and it could be a pain in the butt. Or what companies AI companies do is they create a common protocol of communication. So now the AI does not need to learn 50 different ways to talk to 50 different applications. All of the applications now speak the same language, the same protocol, and now the AI can communicate with that application in a common language. That's what MCP is. It's a common protocol designed for online applications to talk to AI agents, LLMs. Now, an MCP server, as you can infer from this, is the other application that is the one providing the service to the agent, to the LLM. So when you have your agent go through a task or execute on a task, again, let's go back to the example of email. It needs to go to your email application, your email platform. Let's say it's Gmail. In the background, it uses some sort of tool that communicates with Gmail. And when it gets to Gmail, using this MCP, this protocol, Gmail is now able to tell the LLM in natural language what it does and how to use it. So the LLM, if you think about it simplistically, the LLM is basically saying to the application, how do I use you? The application responds with, hey, this is what I do, this is how you interact with me, and these are the available tools that I have for you to use. And the LLM absorbs all that, and based on the task that it's performing, it's able to use the tools that that particular platform provides. And it can go back and forth. So it doesn't have to learn highly complex structures and ways of talking to each individual application. The application provides this simplistic natural language protocol that does all the work behind the scenes. To give you an example, if that in the past, if you needed to interact with a particular endpoint, and you have to have a specific set of data points or required fields that needed to come in a certain way, in a certain format, that has not gone away. But what they're adding is an additional layer that says, okay, the MCP server is telling the LLM, I need you to give me this data. And the LLM provides the data. Now this MCP server is going to take that data and it's going to use its own way of communication with its own application to pass that information across. It receives a response and it just puts it in a way that the LLM can understand. So it becomes like a translation layer that makes communication between LLMs and online applications much simpler, much more standardized. But the concept of having a structure with data fields, and those data fields have to be in a specific format, that has not gone away. And that's why we're talking about APIs here, because the concept of APIs is still very much in use. It's just now for applications that support MCP, it's behind the MCP layer. However, the agent can still communicate to other applications that are not MCP servers using APIs. In that case, you would have to program it, you would have to create the infrastructure for the agent to be able to call upon this API. That's why you still hear the concept of an API key when accessing certain platforms, right? So you as a user, you're given a key. if you're going to access that platform from the back end using an API. So I know it's kind of confusing, so I hope that it's less confusing now. So we talked about how they connect and how do they learn and perform. So let's take a step back. So we said, okay, the AI agent is able to talk to other applications, and those applications tell it what tools are available. However, the agentic layer already has built-in tools that allow the AI LLM to be able to do things locally. For example, there's a tool for using a browser, a web browser. So when you asked your AI agent to do some kind of online research, it is able to invoke a tool that allows it to use a browser and go online and do the research. Okay, so it's if you think of an analogy, the LLM is a brain, the agentic layer is hands that now give that brain the ability to interact with the world, and the tool is like a tool given to a human, right? So you as a human, you have hands, and now you need to nail something. You have a nail and you need to put that nail in the wall, so the tool is the hammer. Now you're able to use that hammer to nail that to the wall. So that's what tools are. Tools are capabilities that are usable, are available to the LLM to interact with its environment. So there's a number of tools that come pre-made with AI agents, but obviously each application can create its own set of tools so that when the AI agent interacts with those applications, they know how to do it. Same thing with skills. Skills are the how, right? So if we use the same analogy of the hammer, we have a hand, we have a tool, and now we need to know how to use that tool to nail something to the wall. So the skills are basically, let's say, procedures or instructions that the AI, the LLM, can invoke in order to learn how to do something. So that's what happens when the LLM is interacting with another tool. That tool basically tells it, hey, these are the things that you can do. These are the tools available to you. And this is how to do it. If you want to do this, this is the skill you need that you need to know in order to do that. If you're going to use that, this is the skill that you need in order for you to know that, to do that. The same thing happens when you want actions to be taken locally. You can teach it skills, like if there's something that is repetitive that you and your AI counterpart, you were basically developing something, and it's something that needs to happen on a repetitive basis, and it was a multi-step thing, you can tell your agent, I want you to save these things as a skill so that next time I want you to do that, you can just invoke this skill and you already know how to do it. So that's what skills are, and you're going to hear a lot about that as you start learning about AI agents. Now, we talked about the brain, we talked about the hands, we talked about the tools, and we talked about the procedures. But those are the what. Okay. Now, how do they complete these tasks, or what other capabilities exist for AI agents to complete tasks? So there's multiple. The first one is something called a hook. So a hook is, for example, some sort of trigger that happens programmatically that tells the AI to start something. Okay. So let's say, for example, whenever an email is received, do X. Or whenever you finish writing code, every time you finish writing code, do Y. Things like that. It's just it's a simple way of saying, a simple way to explain a hook is a trigger that basically tells the AI to perform some sort of predefined activity. And it doesn't have to be necessarily the AI. You can have a program, like an actual program, just run whenever this trigger happens. If the AI is completing something, you can have this trigger invoke some function, some programmatic function to do something else. It doesn't have to be the AI, or you can have the AI perform a function based on this trigger. So that's what a hook is. It's commonly used for initiating workflows. So if you want some sort of activities to happen when something comes through your inbox, then you can use that as a hook. Okay, the next thing that we're going to talk about is crons, or sometimes people call it a cron job. This is something that has to do with the hooks, but it's more like a repetitive, like a batch job, like a repetitive task that you wanted to do on a schedule. An example of it is on a schedule. So you can say to it, hey, every morning at 9 a.m., I want you to get me the news from, X sources in relation to this particular topic, okay? And what it does is it saves that as a scheduled activity. And when the time comes, it, I guess in a way, it wakes up, it triggers the activity, which could involve skills, which could involve tools. Like for example, we said the browser use tool. So it's all connected, right? But the cron job is just a simple way of saying, I want you to perform something on a schedule. Now, the last thing is the workflows. And this is where things start to get really complicated, because you can give the AI agent an open-ended goal and it will figure it out. May or may not be successful, but it will do its best to figure out how to go from A to Z on its own. Or if you want something that has a lot more structure, you can create a workflow so that you combine all of these tools that we discussed and you put them in a pathway to go from A to Z in a controlled manner. So the AI agent has some freedom within that workflow, but it doesn't have so much freedom that it could deviate crazily outside of that framework. The workflow gives it that framework so that you maintain things controlled while you still give the AI the freedom to perform a set of tasks inside each one of those workflow nodes. It works very similar to the way workflows work today in our companies, or like in the corporate environment, where you have established processes, you have established workflows, and the workflows don't necessarily have to change drastically, but those workflows can now be more flexible when you have AI agents instead of human beings being part of that workflow. So, okay, up until now, I think you realize how an AI agent is really more like an employee, basically. You take this brain and you give it the tools that it needs to perform something on its own. But obviously companies want to know, how do you scale that? You can't just rely on one agent. You want to be able to have many things happen using AI. So the way that we scale agentic AI is by using multiple agents, okay? So instead of having one agent do one task and then another, what you could do is you could spawn multiple agents to do smaller tasks, and you can have one agent act as the orchestrator. So you don't even have to control this. You don't even have to program it. You could say to the AI agent, hey, I need you to achieve this goal, and I need you to assign it to different agents, and I need you to be my only point of contact. And that's actually where the agent specialization comes in, because if you have a big task, you break it down into individual specializations, you can have the orchestrator control what everyone else is doing, and those agents do small piece, but they do it really well and really fast. I myself have tried that with the technology from OpenAI called Codex. Codex is sort of a coding platform that allows you to use an AI coding agent. So everything that I have explained up to here is something that you could do with Codex. With Codex, you can tell it to create like a working folder in a computer. Within that working folder, you can tell it to start documenting the fundamentals of a project. You can create a project within that folder. With that project, you can set the the guidelines and the goals for that project. You can have it document the requirements. You can have it document a plan. You can have it document a design. You can even have it explode that design into a set of detailed designs. And you can also have it break up the work into multiple chunks that are highly specialized. And on its own, it can spawn agents that are going to work on those individual tasks, and they can write their own code. They can debug their own code. And the orchestrator, in essence, is the one that's assembling the entire solution together for you. So, I mean, on a simplistic, from a very simplistic point of view, you can say, my high-end goal is this. Go ahead and do all this work and just come to me when it's time for me to test. And yes, I mean, you can be as hands-off as that, and it will produce something. Or you can be a little bit more hands-on, and you can review the plan with it. You can review the design with it. You can provide your own feedback, make corrections, things like that, just like you would in a normal project environment. And you can see multiple agents in action. You can see how it starts to spawn the agents. It starts to control their outputs. It reads what they produce. And you can simply just say, give me the executive summary, and it can do that. So definitely this is very effective, and makes things, if it's well designed, it makes things very efficient. Okay, there's a few more things that we need to learn about the AI agents. Some things that AI agents bring to the table that are also outside of the reach of LLMs is the concept of memory. Now, the memory for AI agents doesn't work the same as with us humans, but it does work much better than having to pass everything as part of the context every single time. So what some of the agents do is they use files, memory files, to either snapshot conversations or snapshot context of conversations, like summaries. Some agents use databases to store data in a vector format for later retrieval. But at the end of the day, what they're trying to do is they're trying to simulate how we as humans would store things and retrieve things when we need them, rather than carrying that over with every conversation every time. Now, something else that another concept that has to do with memory retrieval is the concept of RAG, or it's also defined as retrieval augment generation. So what does that mean? What that means is the LLM, the model, is now able to retrieve information on an ad hoc, on almost like an ad hoc basis. So remember we talked about how the LLMs don't remember anything, that you have to, every single time you talk to it, it brings all the information as part of that context. But the context has limits, and when the context reaches its limit, it starts to forget things. So how do companies deal with that? One way that they deal with that is with RAG, which is, hey, instead of giving you everything every time all at once, what I'm going to do is I'm going to allow you to search based on the context of the conversation. So if you're asking the LLM about something that has to do with some books, some documents, or something like that, you don't have to bring in the entire document as part of that context for it to give you answers about it. What it can do is it can go back to the document. It can search based on a search criteria, based on words, based on whatever you asked it, and then it will retrieve only the piece of information that is relevant to your question. So think of it as like a Google almost, right? But like a more intelligent Google. That's one way that you can reduce. So if you were, for example, at a law firm or something, and you're working with hundreds of thousands of documents, instead of having the LLM bring all of the documents in their entirety to its own context window, it can now just on an ad hoc basis search the database for those documents and for that text, for that particular context, and it just brings in what it needs. Now that once it's retrieved, it has now become part of the context, so it will grow eventually as well, but at least it won't grow as fast as if you had to bring the entire document. Now there's some limitations to that, but at the end of the day, it is much better than just having to bring in the entire document every time. Now the next thing that we're going to talk about is the practical applications of using AI. Well, one of them is to create content. I mean, you see it all the time. I mean, we talked about VTubing and things like that. People use audio, people use video, AIs to create video. They use AIs to create images, visual assets, scripts. A lot of people use AI to create their own video scripts. So it's one of the most known uses of AI. A lot of these content creators use AI agents to create their content, so it's definitely very useful. But moving on from a consumer perspective to a more corporate perspective, you can see how AI is used for process automation, process augmentation. You can even redefine entire processes to be performed by AI agents. So in this example that I have on the picture there, this is a person still still being the one interacting with the process, but now they have the ability to have augmented reality help them make better decisions. So that's one thing. Instead of replacing the person, what it does is it augments the person's ability to do their job. But like I said, in other cases, sometimes you can replace the person by fully automating a particular process using AI agents. Something else that is a practical application of AI right now that companies are using this for is large data analysis. So obviously, companies have collected data over the years for insights, for reporting, for compliance, and that has served them well. However, they also want to take advantage of having all of this data. In many cases, all of the data, there's a lot of data that goes to waste because it's so much of it that it's hard to analyze. But if you have an LLM that can read through all of this stuff and provide insights, patterns, provide information, summaries about it, then it makes things much better. It makes your decision making more informed. So this is something that companies are really digging into, which is how to use AI to provide insights on their own data. Something else that companies are using this for is customer support. I mean, we've seen chatbots being used for years, but now these chatbots are definitely more advanced. I mean, we talked about AI avatars, realistic avatars. We talked about training videos. We talked about all of these things. So now you can have these work in real time to provide customers with answers. As things happen, they can retrieve data, or they can retrieve customer data. They can retrieve product data in real time. So these AI agents, these chatbots, are now being given the tools that they need to be almost self-sufficient and provide customer service in a way that has never been possible before. And an extension of the large data analysis and insights is predictive analytics. So with all of this historical data comes the ability to create predictions. And like I said, when I was talking about LLMs are really good at predicting things. So you can use them to predict based on data patterns on what the trends are going to be for certain things. Now, predictive analytics is not new. It's been around for a long time. However, this used to be very math-driven, very complex. It was super complicated to get something going. But now with AI, these things are becoming more reachable, more possible, and even more accurate. And another application that is used in industry is robotics. Now, you've seen this everywhere. You've seen it in Amazon. You've seen it. Elon Musk has been talking about that. Boston Dynamics. There's a lot of companies that are working on robotics. Now, robotics in industry have been used for a long time in factories, in plants. But now with AI, companies are allowing the robots to have a little bit more freedom and more mobility. Back in the day, the robots have to be static. They were doing tasks that were very specific and programmatic. But now with AI, they can be a little bit more free. They can move around and they can learn about their environment, which is making them much more effective at their job. All right, I want to move on to something else that I promised I was going to talk about, which is why companies seem to be running out of money for AI, complaining that things are getting very expensive or that, it was a bad deal. So why the bad news? I mean, you see headlines, for example, this one that says an AI chief is talking about how token leaderboards are very dystopian. All right, let me give you a little bit of background on that one. It is in the news, it's come up that many companies were using these leaderboards where they were evaluating how many tokens people were using. So one thing that I didn't mention, and I promise I will probably make another video about AI application at the enterprise level, because there is a lot more application than just what I described. But some of the things that enterprises are using AI for is going through documents or helping producing documents, answering employees' questions, basically serving as an assistant to employees or companies that are in the software business. They were using AI coding agents like the one I described in Codex to write code. So they were evaluating how much AI were their employees using by creating these leaderboards that showed the name of the person and the amount of tokens they were using. And as I explained earlier, the tokens have to do with pieces of words. So in essence, what this was measuring was, are you interacting with your AI a lot? Are you asking it to do a lot of good things, apparently, or implicitly good things? Are you being productive by leveraging this technology rather than doing things the old way? So in a way, if your name was associated with a lot of tokens, it just meant that you were using the AI tool a lot. But as this article points out, just because someone was using it a lot, it doesn't mean they were actually being more productive or efficient with it. So this person in this article was basically saying this is dystopian because it's just a waste of money, but you're not really having a way to measure results. Same thing here. See, these executives, they were told about the use of AI and they were like, okay, this is great, I want it. And then they start getting the bill. Why? Because AI companies charge by the token, by the amount of calculations and information that they're spitting out. So if you're having these leaderboards where you're basically forcing your employees to use AI for everything, obviously the AI companies are going to start charging you. And when you get the bill, you go, okay, how do I measure this ROI? But like, where's my ROI? And many companies were unable to really justify the cost based on actual measurable results. And I guess there's one thing that I probably forgot to mention. You cannot, even though you could probably run AI on local hardware, which is possible, it's not efficient. If you want the chat GPT level of responsiveness from AI, you need the power of like cloud servers, right? You need the power of a lot of GPUs, a lot of memory, a lot of servers put together to crunch through all of that data quickly. If you try to do that in-house, that's going to cost a lot of money, or it's going to be slow. I personally have been trying to run AI locally on my computer, and it's not very efficient or quick. So you need the power of the cloud, and they charge a lot of money. So executives are now getting the bill, and they're realizing that, AI costs a lot of money, and it's at this point probably difficult for many of them to measure the return on investment. And something else that I wanted to point out is the effect of software companies mostly thinking that they could replace a lot of developers, a lot of staff with AI coding agents, and then realizing that, oops, it's really not a one-for-one replacement. It's not like, okay, you know what, we have a developer, senior developer, or a junior developer, and we're going to replace it with an AI agent who's going to do 100 times more work for the same time, and it's going to cost us less or nothing. No, it's turning out it's not like that, because you still need to be able to give the AI a framework. You have to evaluate its outputs, and they tend to hallucinate a lot, so you can't just blindly trust it. So why the bad news? Obviously, the technology has the potential. The technology is good. It does produce results. However, if you implement it incorrectly, or if the leadership is misinformed about what it can and cannot do, or sometimes companies have unrealistic expectations of what it's supposed to do because the potential is so great, but the implementation of it needs to be done properly. And one of the other things as to why it fails is because people either don't use it properly, or the user does not adopt the new process. They don't like it, or they prefer not to use it because they don't trust it. So user adoption is small, but another problem. Misuse, sorry about that. Misuse, that's the biggest thing that contributed to these leaderboards. So in the case of these leaderboards, people were not using it to help with their job. They were using it for things that they knew consumed a lot of tokens, but produced no measurable useful outcomes. It was just a way for them to get their name on the leaderboard. So a lot of these things are the reason why in many cases you're not seeing AI providing positive results. But what you don't see in the news is all of the quiet companies that are getting benefit, that did go through the proper implementation path, that they do things the right way, and they're simply just benefiting from AI with more realistic, grounded expectations. And obviously that's not news, so you don't see that in the news. But just because you see all of these bad news doesn't mean that there's only bad news out there. But I did want to bring up the fact that there are bad news, and it's because of, in many cases, these 4 bullets. Well, that was quite a handful, and I didn't intend for it to be so long, but there's so much information out there that I wasn't sure how I was going to be able to summarize it in a way that was understandable. I hope I achieved my goal. And if you want more of these videos, let me know in the comments. Communicate with me, and I will be certain to produce more content. Thank you, and see you next time.